Hello, in this screencast we're going to look at exporting values from Persyst. Specifically, we're going to look at some of the line trends. I previously created a screencast on exporting FFT spectrogram and FFT power, as well as aEEG, and then exporting those to comma separated values. We're going to look a little closer at that, and I'm going to look at line trends, because line trends, of course, will only have one value per epoch, except for aEEG, which will have 5 values per epoch. This is Michael Guest, VP of Research and Clinical Applications, and the two recordings we're going to look at for this is this first one is a carotid endarterectomy, and the other one is a neonatal recording with a seizure detection during that, and we'll go ahead and get started. So this is the default versus baseline comprehensive trend panel. We dropped a baseline, actually an automatic baseline here, and we're just going to page forward through the trends. I'm going to close these windows on the right. Of course, you may decide to leave them open or closed depending on what you need, but this will give us a little bit more display. And we're looking at this in a bipolar longitudinal montage on the left, and this is the default trend panel. We'll just go ahead and page forward here, and 30 minutes at a time. So as I click this double arrow, it takes me 30 minutes. The single arrow, of course, will take me a little bit at a time, and I can nudge the trends over by clicking that, or I can click and hold down on the trends and drag them over. So this is where the clamp has been applied to the carotid. And so let's go ahead and see if we can make this a bit more relevant to the pre-clamp period. So what we're calculating at the top, of course, artifact intensity, seizure probability, rhythmicity spectrograms left and right, FFT spectrograms, and we can see the loss of faster frequencies over the left hemisphere there during the clamp. The asymmetry relative spectrogram, since we lost faster frequencies on the left, this turned red, indicating that the right became more prominent with respect to the left. But did the right increase in amplitude or drop? Well, from the FFT spectrograms and the aEEG, we can see that the left actually lost amplitude. And on a versus baseline trends, we can see in that alpha range where we've lost the bulk of that amplitude compared to the initial background that was set at the beginning of the recording. But we don't know what the patient state was during that initial part of the recording. They may not have been under anesthesia yet. So let's go ahead and mark a range of baseline prior to that. So I'm going to pick a spot with a few dropouts. I think we'll just go over this area here. I'll place my cursor where I want that baseline to begin. And this is actually a typical application where you're going to set a baseline based according to patient state, because patient state, of course, will change the content of the EEG. And we're calculating versus baseline is statistical measures from that baseline using an empirical null. So let's just click new baseline, and we can do 360 seconds. I'm going to go a little closer to that change here, but not too close. So 698.4 seconds, I can get precise with the placement here, but really I just want to pick a state prior to clamp. And in this case, and I'm going to set the button here to add baseline. I'm going to call this pre-clamp, because I want to look at statistical measures to show, well, how did the EEG change when they apply the clamp? So we can see here the versus baseline left hemisphere versus baseline right hemisphere. It's looking at these spectrograms here for left and right, and as we would expect, we have negative z-scores here, and if I right click and show values, it'll show me the peak value. Same thing with the spectrogram. So if I were to click here in the middle of this change, it's telling me what the maximum, what the frequency is at the maximum level for the spectrogram. So in this case, this is probably a little more helpful. And so is this. So we're saying we have a 57% asymmetry at 14 hertz. And this is saying that the greatest z-score change is at 7.5 hertz. It's down 11.3 z-scores. That's a lot. And then there's a bit of rebound after they remove the clamp. And we have a rebound in the slower frequencies here on the left. So that's what's happening there. And it's expressed in z-scores. So we can see a change where we lose frequencies compared to the baseline, or we gain them. So let's see what happens with alpha delta ratios. Now if we go to the standard trend panels from 12, 13, we've included those in P15 as well. And what we'll do is go ahead and pick alpha delta ratios by quadrant. Now what we're showing here is left and right hemisphere. left and right anterior, left and right posterior. We have the asymmetry spectrogram, asymmetry index, aEEG. By the way, when you're doing ratio trends, we always like to show some form of amplitude trend because ratios don't explicitly include any amplitude information. You can have very nice ratios but lose a tremendous amount of amplitude, or have other changes that are related to amplitude but not necessarily change in the frequency content, and those are clinically important too. So we like to include an amplitude trend to add context to ratios. Okay, let's go to some of the new trend panels. So we have alpha delta ratios here, but now they're organized vaguely according to, of course, the electrodes aren't sitting directly over anatomical areas, but this is a request. So we just label them by the electrodes. We don't want to say this is corresponding to perfusion areas because, again, the electrodes don't sit necessarily directly over those. But now we're looking at F3, C3, P3 versus F4, C4, P4 for ADRs. Then F7, T7, P7, and their homologs. Then P3, P7, O1, and its homolog here. So we still have 6 trends, as we did with quadrant, but instead of hemisphere and then by quadrant, we've displayed them this way. So this is another point. You can display alpha delta ratios or other trends by channel or by channel groups. And if you want to see what's in a channel group, they're explicitly stated here. But if we go to Preferences and Trend Preferences, and then go to the Channels tab, I can look and see what channels are in these groups. Of course, these are labeled with the channels that are in them. But if I want to see what's in the asymmetry anterior, those are the channels that comprise that. And if I were looking at left anterior, those are the channels there. So you can see what channels are in any particular channel group by selecting Preferences, Trend Preferences, and going to Channels. So these are all the channel lists that are included by default in P15. Select Cancel here. Now we had one other bit of information that can be helpful. We'll go to Other Panels, and we're going to select VsBaseline ADR. And what we've done here is, instead of just having the alpha delta ratios, and we can see, as one would expect, the left ADRs are dropping, and we could look at them by their respective areas on the scale. But we can also calculate z-scores. And so when we compare it to this baseline, which, you know, for another clinical application, that baseline could have been the day before, or 2 days before, or 2 hours before. It depends on where you set those baselines. There'll always be an automatic one set at the beginning of the recording, but you may set your own as well. 5 minutes, roughly 5 minutes is a decent minimum to give you enough samples to calculate that empirical null. Longer is okay. Generally, you don't want to span big state changes because, again, that'll be incorporated into the null for those z-scores to be calculated. Now these are single values because we have single value trends. This is one number, and we can see the ADR for the left goes from 1.27 to 1.16, and it's calculated an empirical null from the ADRs in the case of these thin colored bands, which are appropriately labeled as well for left and right. And so when we go here, we can say there's 10.7 and a 1.96, both negative values, drop in z-scores from the baseline. So we can get z-score statistical metrics for spectrograms, but we can also get them for single line trends. So if the question is okay, I've had a drop or change, an increase or a decrease in these ratio trends, statistically, what was that change? How many z-scores am I from that empirical null that was calculated? You get it right there. So exporting these values, you can select various trends. Let's go ahead and just make this full screen trends. And let's say I want to export the values for the entire record. I wouldn't mark a range. But if I want to export them for a longer period, but not the entire record, let's say I want to go from where I started the baseline to about a little over here after those changes abate. So what I could do is right-click, Insert Range, and I'm going to stop here. So I'm going to export trends for that range of information, or for that range of data. And I'm going to click here. You can Control Select, or you can hold Shift and select a range of trends. So I'm going to select the ADR for these channels, their accompanying z-score values, and so forth, all the way down. And I'm going to skip exporting these others. So you have a choice of what you want to export. And then I'm going to go to Tools, Export Channel Trend Values, and we're going to drop this on the desktop here. And it's created as a CSV file. So let's see what's in that CSV file. What we have here, when we use the default Excel settings to open the comma-separated values, then, of course, using those comma-separated values, you get nice columns for each one of these. Now, the labels are up at the top, and they stretch over because each one of these has more text that would fit there, but you can just arrow over and see what each one of these I columns is showing. And so the first column is the ADR for those left anterior channels, and then we have the right anterior channels, and then we have the VsBaseline values for that. So this is a ratio for left anterior channel set that was described, right anterior, and then the z-scores. And here's the time. So this is the time, elapsed time, number of seconds into the recording where I placed that, and you can see here that it's incrementing based on the epoch length. And then this is Microsoft OLE time, which encodes both the date and the number of, and the percentage or the proportion of time after midnight as a fraction. And you can see that, of course, the number, if we go up here, we can see that is indeed lots of precision, but yes, it gives you the percentage of a day forward, and this first part is the date. That's calculated. You can look it up on the web to see how Microsoft OLE time is implemented, but anyway, that's what's been exported. That's why you get all these columns. So let's look at one other type of recording, and that will be a neonatal record. And we'll look at how aEEG is exported, because again, this is a single value, but if we zoom in on this much closer, we can see that each epoch is rendered using two values, min and max, as aEEG is described. So with aEEG, we'll do full wave rectification of the signal so that all the values are positive, and then filter it using the Maynard asymmetric cerebral function monitor filter from 2 to 20 Hertz, which is described in the help file. I'll bring that up in a minute. And then it's rendered showing the minimum and maximum values using a semi-log scale. So from here it's linear, or I should say linear log scale. This goes 0 to 10, and then 50, 75, 100. All right, so we're going to export these values and see what they look like in the spreadsheet. Restarting the recording. You'll see the clock in the bottom right is incremented by an hour. I took a meeting, so we'll try to pick up the thread here. So we talked about aEEG, how these are the epochs. We're looking at 60-second trend duration during the seizure, happens to be. And you can see that these are min-max, but it's calculating more. It's calculating min-max, 25%, 75%, and median. But it's only displaying min-max. That's the definition of the aEEG calculation. If you click the help button over here, and in Persyst Research, there's a different way to access the help system, and we can always share the guide. But if I go down here to trending, actually, we go to the trending book, we'll go to trend types, aEEG, and here's the description. That talks about how aEEG is calculated and the filters that are used. So, can we change any of this? Answer is no. So if we go to this aEEG trend and we click the options here, we can change the color and we can change what it's calculating, but everything else is fixed function there. And if I go into the engine parameters of this and click aEEG and go to view, you can see here it's doesn't let you go into any parameters. So what I'm going to do is pop up a research version of Persyst, overlay that. So I've just launched a different window. This is non-clinical use only. This is P15 research. Now when I go to move the comment list out of the way, go to trends full screen, and we're just going to click the add button. I could go into the preferences and add as well. Say we do a new trend, you'll see that research has aEEG Plus with custom filters. It's going to create a new engine, and the idea here is that I can as in the other aEEG, the clinical one, I can select left hemisphere or any individual channel, and I can edit the engine parameters now. So sampling rate 64 Hertz by default. Time constant, you could go ahead and say, I'm just going to use the CFAM 79 to 86, and I'm going to apply a notch filter, and you'll get the same thing. But what you can also do is you can change the epoch duration from the default 1 second, and you can modify other parameters. So the aEEG Plus is not aEEG, it's actually a research version of it where you can modify parameters in this. So now the other thing that you can do is you can set the gain. So the default is 100 microvolts, but you can go all the way up to a millivolt. So that's aEEG Plus. In creating custom filters, if we go to the EEG page, you can click one of the filter banks, and that was set rather low. Let's go here, go to filters at the bottom of the filter tab. So I just clicked the filter and went to the bottom of the range. And here we can go to a custom filter, FIR versus IIR. You have your choice. You can even do parametric sort of filtering. Properties, and we can pick different filters here and then create them. So once you've created them and named them and set the frequency, bandwidth, sharpness, all that, you can do your custom filter creations, name them. You can use them in aEEG Plus. So that's completely customizable. Now, aside from that, these values are available, all 5 of those values. But let's go ahead and change the trend duration here and look at an optional trend panel. This is aEEG Analytics. And what this panel is going to do, and this isn't part of the standard neonatal configuration, is we're looking at some of those values. If I click on a time trend, this is, for instance, using 1 minute and looking at minimum values. And so we're plotting those along the bottom here, and then we're looking at aEEG max. You can see it follows the outline of that, but it's doing it over 1 minute epochs. This, if I look at the 1 hour and go to time, this is set to use, as the description indicates, 95th percentile over an hour running average, and this is using the 5th percentile for the other end of that. And you can see it's just above the bottom here. So you can see that these two diverge during the seizure. So you get a lower resolution and a higher resolution version of some of the output of that aEEG. So let's go back to the 3 channel and look at what happens when we export aEEG values, because again, we're going to get more than 2, more than just the min-max. Let's go ahead and indicate a range. So insert a range, and I'm going to select just the aEEG trends, and then I'm going to go to Tools, Export Trend Values, and we'll drop this up on the desktop. And now we'll look at that in a spreadsheet. And as prompts, we get multiple values for each one of these. So clock time, we get Microsoft OLE, elapsed time into the recording, and you can see these are incrementing by 1 second epochs, and we have 5 values for each one of these. And so there's the min and the max, and just in case, we'll look at this little key here. This tells us what we have in each one of those columns. As I wrote that down earlier, max, min, median, 75, 25. And so if we bring up the spreadsheet to look at, there it is. That's exporting aEEG values. You get multiple ones for each channel. And again, this is the default trend, FP101, FP202, C3, C4, in that particular panel. But you're not limited to that. So for instance, we have all channels. And if you're recording some derivation of this electrode application, you can do groups of channels or individual channels. And there's a way to configure that. So for customizations or other inquiries, we're always happy to meet by web conference. This is Michael Guest, VP of Research and Clinical Applications for Persyst. Thank you.